Thanks, Thomas. Hello, everyone. Um, Paul, also thanks for the amazing presentation. Couldn't have a better introduction, I would say. The reason that I think all of us are here is because hardware development and manufacturing is changing. It's changing rapidly, it's changing radically. And what I want to zoom in this talk is on the development process and especially how open online collaboration is driving that change. And interestingly, that's something that was first understood by individuals, amateurs, hobbyists. And one of them was a designer from Paris called Gaël Langevin. And Gaël had designed a robotic arm as part of his work, and he was done with the project and then realized, like, I just want to share my designs and see what people do with that and see what happens. And that sort of got out of hand, and I'll show a little video about that. That should. There we go. Yeah.
Crazy idea, almost impossible, but you just do it. It doesn't matter. It's the first open source robot you can 3D print, humanoid type of size. You can download this thing, you can make it yourself. I see you. I'm not the only one building the robot. The more people putting ideas, developing parts. That's what is the goal of that community. Today I really hope, and I can see it, it's going in universities and schools and makers, there's all kinds of people using it, actually more than if it was just a small little company selling my parts. I think you can build your own robot in your workshop and be happy with it. If many people can start to build the same robot and share the same ideas, and I think it's more interesting. If I had done patents, maybe it was bought by a company, I would get some money with it, but that's it. It stops there, it doesn't go any beyond that. It's fun. First of all, share with the information and you get back. Somehow giving, you always get back.
So hardware development is becoming decentralized, collaborative, and open. That's one of the things that Gaël proved. He proved it back in 2012 already. That was the first time we met him. Soon later we shared his designs on the platform. And there are four drivers, main drivers of these changes. And I want to briefly touch upon them, briefly because most of them have already been spoken about here on the floor by the other amazing speakers. And the first one is pretty obviously digital manufacturing, and especially that it's become globally accessible. So whether it's that through cheap, affordable desktop printers, or whether using a service like 3D Hubs, like Francis showed in his presentation, and that allows for rapid low-cost development, distributed teams, local and small batch manufacturing. From idea to market is faster, and a lower entry barriers to participate in this hardware development process. The second one, very important, the basic building blocks of a lot of hardware projects have dropped dramatically in costs, and they're globally accessible. You can access the global supply chain, you can go online, order a technology like an accelerometer, and get it shipped to you within a few days from all over the world. Again, lower cost, but also increasing the scope and quality of what people can make. I think a very important thing, and I think Autodesk kind of showed it, they started operating not so much as a traditional hardware company, but almost like a software company in the hardware world. So the culture of software development is shifting to hardware development. That's about lean, iterative, rapid, and it's about open source. Faster, low costs, and open source is providing people access to knowledge and files they can use to build upon, so again, lowering the barriers for you to participate in hardware development. That sort of coincides with a global shift in our society towards a more flexible workforce, towards more entrepreneurship. There's a maker movement that's advocating making, local production, etc. And there are new channels to fund and to bring your ventures to market. This all results in a greater number of smaller players, whether it's individuals or startups, getting into hardware development. A democratization of developing hardware. So we see lower barriers, more people participating, and that results in more innovation. It's proven by MIT that when users of products get into the development process and start innovating, we see more successful innovations, and we also see innovations that are better for social welfare. People start addressing problems that are not being addressed by traditional market players. There could be things around sustainability, there could be local problems that are just too small for companies to see a profit in. And that empowers people to solve their own problems. It also solves people to learn engineering skills and to start businesses. So prerequisites for this are effective online collaboration, again shown very beautifully in the presentation of Paul. It's having access to resources to build upon, open knowledge, open files, and having access to a community, a global community that can help you out, that you can ask questions to, that you can start collaborating with. So I'm very passionate about that, about the opportunities that that brings, and therefore the mission of our company, Wevolver, is to enable anyone, wherever you are in this world, to start developing hardware, to start creating these new technologies. So Wevolver, an online collaboration platform for developing hardware. It can be both public and private projects, so both open source or projects developed within companies and engineering teams. And our users are sharing knowledge, sharing files, things like 3D models, but also electronic schematics. They're sharing assembly instructions and then iterating with each other on the design. There is a video behind it, so we may be able to try if you guys can click on the slide if it plays. There we go. I'll let it run for a little bit to show you. So this is what the platform looks like. And I want to dive in this specific project a bit more deeply, because it's showing something that, that we learned after we'd launched this, September 2014. Yeah, so we launched September 2014. We now have over 5,000 users. There are over 500 open source hardware projects on the platform. That's growing rapidly. At the current growth, in 12 months we will have tenfold as much projects as we have today. And yeah, we see that it's now starting to become recognized by bigger players as well, through the Accenture Innovation Award that we won, the South by Southwest Innovation Award, a Nominate Trust Prize. And in the time since our launch, we learned an important lesson. We thought that the majority of the users of our platform, the majority of people starting to share open hardware, were people like Gael Langevin, individual designers, often besides their core job or project, sharing as a hobby. But what we learned is that actually the majority of people sharing open hardware projects on our platform are startups or small hardware companies. And we've seen it actually increasing over time. There's a change happening here. And this is one of them. This is a company from Japan called XC. They're developing bionic arms, electronic myoelectric prosthetics, so they're controlled with a sensor that is on your muscles. It picks up electronic signals, and with that you control the prosthetic. So those are expensive prosthetics, 10,000 euros a piece, only available to a limited amount of people. And that was something that bothered the guys behind XC. And being of this generation that understands software development and understands that culture, they decided we're going to build a simplified 3D printable version that can be built with off-the-shelf commoditized electronics, and we're going to make this open source. Because then we can bring this to more people. We can also see what happens if we put this in the hands of a big audience. How are they going to innovate on this? So, because as you can see, these guys were very good in engineering. It's very well designed, very well engineered. This project got very popular on Wevolver. Within a week, 1 million people had seen about it because people started sharing about it. And one of them was Matt Cashman, and this is the brother of Matt, Ryan, and Ryan had just lost both of his arms in a work accident. And Ryan, he's from Texas, he wasn't insured to get a prosthetic. The most that he would get was a hook. Now that XC had released their designs, and the global community was excited about it, Matt Cashman could help get his brother the prosthetics that he wanted and that he needed. So within 2 weeks' time, 40 individuals from all over the world started collaborating on improving the designs, customizing the designs that XC had provided for Ryan. And what was incredible to see the backgrounds of these people. These were people who either were engineers at very, very top companies, from a semiconductor company to manufacturing companies, or it were small companies themselves who jumped in. Manufacturing companies, 3D scanning companies, they all helped. There was even somebody in the team who had never done anything with making or 3D printing herself. It was a hand surgeon from Melbourne who knew so much about hand transplants, but also about prosthetics, and was helping the team with her knowledge. So with that, the team kept innovating and iterating. Ryan got customized prosthetics that were so good that he could use this for weightlifting, it was his personal passion. And what's more exciting, that the improvements the team made were all shared online, so anyone can now build upon the knowledge they gathered, the better files they created, and this project just keeps innovating over time, and we're seeing more and more spin-offs of this project happening. So again, this process shows how digital manufacturing, cheap electronic components, and the idea of open source is bringing open hardware to a sort of a higher standard and allowing people to innovate, and is changing how hardware gets developed. And again, it was a startup that shared this project. So I want to show a few more examples of this and go through them a bit more quickly than this story. But this, what you're looking at here, it's not a gun, it's a smartphone controlled telescope. It's developed by a consultancy agency who does the consultancy for NASA and ESA, very high end. And the goal is to create a community of citizen scientists, citizen astronomers for asteroid hunting. What this thing can do, I'll show you what it looks like. It automatically points towards stars and galaxies. You can take photos and do light measurements. And apparently, there is a huge gap in knowledge about the night sky in the southern hemisphere. There are fewer astronomers, fewer observatories, and by having a cheap, well-engineered telescope, much more people can get participating in this process. And this is one of the pictures taken with that smartphone-controlled telescope. And again, a company sharing their designs. It's very well engineered. We met them at a Maker Faire, and the project, in my eyes, was like, it's beautiful, let's put it on Wevolver. And they said, no, we just want to like tweak the design a bit till the moment that we're confident enough for people to start building it themselves. They took another full year till they said, like, okay, now it's good enough. So again, a startup that's not just sharing for anyone to like, okay, my files are done, I'll put it online. No, they had a mission, they engineered it to the point of perfection, and then start sharing what they did. This is another Japanese company. They called Plan. This is the Plan 2 robot, designed for people to start learning robotics, 3D printing, and software engineering. They did a Kickstarter in 2007 with an early version of this, came back last year with a second successful Kickstarter with a new iteration of this project. And their business model is to sell kits of this robot, or even fully assembled robots, for a higher price. But you can also download all the files, make one yourself, 3D print it, and start building your own robots. This is an interesting example of a company that started after a maker hobbyist project, was very successful. Open ROV from California, started by two guys who developed an underwater drone they could use for exploration, then found out how popular that project was among people all over the world who wanted to use it, and they formed a company, turned it into a startup, and are now shipping both the 2.0 version of their original design, but also a proprietary high-end version that's much more expensive. So they're building a business model around having both open source and proprietary designs next to each other. I want to show this version of this project because this is someone who wants to make a company out of this right from the start. So he released this project on Wevolver, but not all the files yet, because he's still iterating it to the point that it makes sense for his business to share all the designs. It's a framework that you can use to reuse old bicycle parts. So often when motorbikes get discarded, it's because their frame or something is broken, but the motor block itself is still perfectly valid. So you can laser cut the frame that you see, put in an old motor block, and you have a very fast motorbike again. This is Reid from Austin, Texas, building large-scale 3D printers. They first built a proprietary version, then went to Kickstarter, raised a lot of money to R&D a better version that would be open source, and they released that a few months ago. It's a very, very well designed product. We went to Austin to check it out. And this is the last example.
It all started with me getting into an injury a couple of years ago. This had impacted my mobility. And since I'm a software engineer by trade, I thought about how can I use technology for making my future more convenient. My name is Sune Petersen. I'm from Faraday Motion, live in Copenhagen. In Faraday Motion, we are creating the future of urban transportation. So it is an electrical skateboard that we built. It contains a top lid. There's an under lid that protects water from coming in. There's a battery compartment in the back, the two brackets in the side. It's basically giving the strength. And then there's an inner bracket mounted for the motor. It's controlled by a mobile phone in this version. And the tilt of the mobile phone actually converts into either accelerating or braking. Everything is open sourced in our concept, so the whole crowd is going to provide additional innovations and things that we could never imagine ourselves.
Yeah, so again, like a very maker-pro approach to open source, and that's I think sort of the line here in all of these examples. We seeing open source hardware really becoming part of strategy of people to build a business around, and very interestingly that this guy is a software engineer who brings that culture again to hardware. So I want to leave you with this image. What we see here on the left is an illustration of the different version of Linux, the open source software operating system that's been around since the 90s. And because of its open source nature, people start making different iterations, different clones of it. And you'll see then a sort of evolutionary tree of all these different versions. And actually, because this is such a massive project, this is just zooming in on one branch of it. The rest of the picture just would not fit on this slide at all. But that is sort of the model that we know from open source software. This is proven. This is how successful open source projects work. And Linux is a nice example because it's a software project around which a lot of companies are creating a business. The other image is showing the RepRap 3D printer project, which was released in early 2007. So quite a few projects that we see here on the fairground are derivatives of that original printer. Ultimaker is one of them. And what's interesting that this graph, although it's less dense because of the sort of younger nature of it, it's showing the same evolutionary pattern. So knowing what open source software has done for global innovation, we can sort of extrapolate and understand that this will happen for open hardware as well. Those four drivers that I showed, digital manufacturing, commoditization of electronic components, software culture, and now societal shifts, they keep continuing. There are currently over 30 million engineers and designers all around the world. That's rapidly increasing. STEM education is becoming more and more a focus point of governments all over the world. And I'm thrilled to see what's going to happen. I invite you all to check out the Maker Pro area, where some of the projects that I've showed are shown, like the telescope, etc. And yeah, I'm curious to see where in the next few years the Maker Pro movement is going to go. Thank you very much.